Hello, welcome to your next lesson. Today we are starting our new topic of memory, and we're going to be starting with short-term and long-term memory. So this is a brand new section in your folders. Make sure you have your textbook, your notes and your pen all ready to go. I want you to think about the following questions. Firstly, how have you used your memory today? So as soon as you woke up, how did you use it? You probably used it to remember where you were, so you remembered that you were at home. You probably used it to remember to brush your teeth and get changed and go to mentor time. Maybe you remembered something that happened yesterday or last week, potentially. What would happen? How would your life be different if you had no memory? What sorts of things would change? What kind of different things do you remember? You might have some really personal childhood memories that you remember, or maybe you have good memory of doing certain procedural tasks, like maybe you're really good at playing football or baking. What techniques do you use to improve your memory? So you might have some really effective revision strategies that you use to remember the content. You all know that I'm a big fan of mnemonics, that they really help me to remember things. Or you might learn things visually, so it might help you to draw little pictures of things, and that helps you recall content. Also, do you forget things easily? I know I do. If someone tells me something, by the day after I've usually forgotten, which is terrible. And I always forget to do something if I don't write it down. So all these questions are some of the things that we're going to look at in our new topic of memory. It's a very enjoyable topic, at least I think so, because it tells us a lot, and hopefully we'll learn some interesting things along the way. So this is the sort of thing that we're going to look at. Today we're starting with short-term and long-term memory. We're going to look at coding, capacity and duration, and I'll explain what that means on the next slide. We're going to look at two memory models, so the multi-store memory model and the working memory model, which explains how we store our memories and that the process that allows that to be done. We're going to look at different types of long-term memory. We're going to look at why we forget things and what would help us remember things better. And then we're going to look at the accuracy of eyewitness testimony and things that affect that. And we're going to look at some interesting studies when we do that. And then finally, we're going to finish off with a cognitive interview, which is a technique that's used to improve the accuracy of eyewitness testimony. So short-term and long-term memory. What is the difference? Examiners love this question. So short-term memory is memory for present or immediate past. So it's things that have happened very, very recently, like maybe you remember the daisy that I just showed you on the first slide. Another example is, say you are out with friends and you say, okay, I'll go order the drinks. Then you might have 6 people telling you their drink orders. You remember it. When you get to the bar, you recall that information, but then maybe like an hour or 2 hours later, you probably don't remember the order, or especially the day after, you probably wouldn't remember. That's your short-term memory. It's things that last very temporarily. Whereas long-term memory is recalling events that happened in a more distant past. So you might remember where you went on holiday last summer, if you've managed to get anywhere. You might remember a really good birthday party that you had once when you were little. So it's things that happened in a more distant past. And there's 3 ways that we can tell the difference between these two types of memory. One of them is capacity, so how much can they hold? Duration, how long is the information stored for? And encoding, how is the information stored, or how is it written into our memories? So if you get a question like this in an exam, you can talk about these 3 things and the differences, which is what we're going to do this lesson. So a little task for you first to test your short-term memory. So what I want you to do is I want you to cover all of the columns except the left one, and then just read it. So you should be able to read 2, 4, 8, 1. And now what I want you to do is close your eyes and try and recall that. So 2, 4, 8, 1. Okay, that should be fairly easy. Now try the same thing with the 5-digit number. 4, 5, 6, 2, 9. Close your eyes. 4, 5, 6, 2, 9. Still fairly easy. So pause me This is also in your textbook, or you can do it off the screen. So pause me and have a go and see if you can reach the 9-digit number. So some of you would have probably found that very easy to recall 9-digit numbers. Some of you might have found it a little bit more difficult. Last year I had a girl in my class who did this, and then I asked her like a month later and she still remembered the 9-digit number. So some memories are obviously better than others. But what we just did was a digit span test, and it was testing the capacity of our short-term memory. So how much data can be stored in a memory store? That's what we look at when we talk about the capacity. It's about how much is in there. So short-term memory has a very limited capacity, whereas long-term memory, the capacity is potentially infinite. So you're not going to experience something in your life and then your brain is going to say, oh no, long-term memory is full, actually I can't put that in. With long-term memory you can put as much as you possibly can in there. Capacity can be best explained using the digit span test, and that's what we've just did. And Jacobs, back in the 1800s, used a very similar test to the one that you just tried to assess the capacity of short-term memory. And what he found was that the average span for numbers was 9.3. So people on average could remember about 9.3 numbers. So if you manage to remember the 9, you are about average. And it was a little bit less for letters, so people on average could remember about 7.3 letters. So why do you think it's easier to remember numbers than letters? There's no real right or wrong answer to this because it's purely hypothetical, but one explanation is that there are more letters than numbers, so there's only 10 digits that we'd have to remember if you include 0, and there's 26 letters. So that's maybe why it's easier to recall numbers. Okay, now you're going to see a series of words, and I'm going to leave them on the screen for about 20 seconds, and I just want you to try and remember as many as you can. Don't write them down. Okay, so now pause me and write all the words that you remembered. How many did you remember? And how did you try and remember them? So when I look at something like that, I don't know if any of you would do the same. I would probably try and make up a little story. So I pictured the little cat in a house, but you might have a different way to try and remember them. Just want you to look at this for about 5 seconds. How many dots did you see? There were actually 12 dots, but I assume that most of you probably said that there was less. And there's an explanation to this. So the capacity of short-term memory is probably less than 9. So we can only hold about 9 items in our short-term memory at any one time, which could explain why you didn't get it right, or you might have done. If there were 5 dots, then your short-term memory would have been a lot more accurate at recalling that, because it's less capacity, less to process, so therefore you would have probably got the answer right. So research into capacity. The most famous one, apart from Jacobs, was Miller, and I want you to try and remember Miller's magic number, because this always comes up in the exam as well. So he found that the amount of items that we can store in our short-term memory is about 7 plus or minus 2. So at the high end we've got 9 items, at the low end we've got 5 items. He noted that people can count 7 dots flashed onto a screen, but not many more. And he found the same is true if you're asked to recall musical notes, letters, or even words. So in the word task that I gave you, maybe you managed to remember about 7, which was probably average. Miller also found that we can recall 5 letters as well as we can recall 5 words, and that we can chunk things together to remember them more easily. So chunking is a very important tool in allowing us to hold things in our short-term memory, and is when we separate things into smaller chunks. So for example, if I ask you to recall your telephone number, you probably wouldn't tell me every individual digit. You'd probably tell it me in series of 3s, or maybe you chunk it into 4s, but you probably wouldn't recall every single digit. So chunking is very useful in allowing us to recall information. So there are some problems with the research done on capacity. And it's been found that the capacity of short-term memory may be even more limited than 7 plus or minus 2. So there's a research done by Cohen, and he believed that short-term memory may be limited to just 4 chunks. So remember, chunking is just where you put digits or letters together. Visual information rather than verbal information also found that 4 items was about the limit. So this suggests that if we consider Miller's magic number, plus or minus 2, 7 plus or minus 2, then it's probably, the capacity of short-term memory is probably going to be at the lower end of Miller's range. So it's going to be about 5 items. So this is a weakness because short-term memory capacity isn't as extensive as we initially thought. A positive, however, is that the size of the chunks matter. I'm going to explain what this means. Simon found that people had a short-term memory span for larger chunks, such as 8-word phrases, rather than smaller chunks, such as 1-syllable words. So this is suggesting that our short-term memory has a limited capacity and it refines our understanding. So it's providing support for the research from Miller and Jacobs that yes, our capacity in short-term memory is very limited. And another weakness is that there are individual differences in our short-term memory. So it was found that 8-year-olds remember an average of 6.6 digits, but then 19-year-olds recall 8.6 digits on average. Why do you think this might be? Why do you think 19-year-olds are better than 8-year-olds at remembering things? It could do with an increase in brain capacity, and also as we get older we develop strategies to try and remember information, such as chunking. Another example of when we chunk things is probably your registration plate. You probably remember the first bit of it and then the second bit. So it's a very useful strategy to remember things. Moving on now to duration, so how long something stays in our long-term and short-term memory. The duration of long-term memory is potentially that it lasts forever. In short-term memory, has a short duration, unless the information is repeated over and over again, which is why reviewing topics that we cover is so important when thinking about your exams. So I want you to go to page 44 and pause the video and just summarise the research on duration of short-term and long-term memory into about 3 bullet points. I just want you to read it, try and understand it. The first research that you should have read was about the duration of short-term memory, and this was done by Peterson and Peterson. So 24 students were tested over 8 trials, and what they had to do, basically they were given a consonant syllable, so for example THX or ENT or whatever, and they were also given a 3-digit number. And this 3-digit number was important just because it was the number that they had to count down from. And then they had to recall the consonant syllable after a retention interval of 3 seconds, 6 seconds, 9 seconds, 12 seconds, 15 seconds, or 18 seconds. So basically what this would look like is you would have to remember THX, so you'd have to try and repeat that in your head, THX, THX, THX. But at the same time, you're having to count down. So you would start with 512 and you'd have to count down in threes. And then after whatever retention interval you have been chosen for, you would have to say the consonant syllable that I was given was THX. So they tested to see how many people would remember that. And what they found is that participants on average were 90% correct over 3 seconds. So if they were given THX and then 3 seconds later, after counting down from 512, they had to recall it, then the 90% of them were correct. 20% correct over 9 seconds, so it dropped dramatically within those 6 seconds, and only 2% over the maximum, which was 18 seconds. So this suggests that short-term memory has a very short duration, so less than 18 seconds, as long as verbal rehearsal is prevented. If we can verbally rehearse something, then short-term memory can last longer. So if you are asked in an exam what is the duration of short-term memory, you would have to say around 18 seconds. Can you think of any problems with Peterson and Peterson's study? We need to pause me now and think about it. So something that you might have thought about was the fact that it was testing short-term memory duration in an artificial way. You could say that it's lacking mundane realism, because memorising consonant syllables does not reflect everyday memory tasks that we have to do. But you could argue it the other way, because sometimes we do have to remember things like postcodes, phone numbers, credit card numbers, etc. So it does have some reference to everyday life. There's another problem with it, and that is the fact that results may be due to displacement. So displacement is something that we're going to look at when we look at the memory models, and it's a type of forgetting where the information isn't readily available or it's replaced with something else. So because participants were counting numbers in their short-term memory, this displaced the syllables they had to remember. If they hadn't had to count numbers in their short-term memory, remember when they were counting down from 512, if they hadn't had to do that, then the duration of short-term memory might have been a lot longer. Reitman used auditory tones instead of numbers so that displacement would not occur, because sounds don't interfere with verbal rehearsal, and found that the duration of short-term memory was longer than what Peterson and Peterson found. So instead of having to count down from 512, participants, when they tried to remember the consonant syllable, THX, 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 would just hear some auditory tones, and that didn't interfere as much because displacement didn't happen. The information wasn't overwritten. So forgetting it in the original study, in Peterson and Peterson's study, was due to displacement rather than decay. Decay is just when you forget something, it just leaves your memory. But we're going to look at that more when we look at memory models. So therefore it wasn't measuring the duration of short-term memory. You've probably noticed by now we're doing the evaluation of the studies as we go along. This is my Year 11 leavers photo. So this is me and the rest of my year group. So this relates to the next study, which I asked you to look at, about the duration of long-term memory, because participants basically had to look at their yearbook and try and remember as many names as they could. Looking at this now, I could probably only tell you about 80%, and that was about 11 years ago. So it'd be interesting to see how many names you could remember, seeing as it was only like a year ago for you guys. I wonder if you've... I am here with the massive fringe. So Barrick had 400 people of various ages, and they were tested on the memory of their classmates. So how they did this was photo recognition test of about 50 photos, and then they also did a free recall test. So free recall test is just when you recall everything that you can. So they had to give as many names as they could remember. And those participants that were tested within 15 years of graduation were about 90% accurate in identifying faces. And after 48 years, this declined to 70%, which is still quite high if you think about it. 48 years after graduation, you still remember 70% of the people. I think that's quite impressive. In the free recall test, those graduating within 15 years were about 60% accurate in listing the names of their classmates, and it dropped to 30% after 48 years. So basically saying that the duration of long-term memory does decrease with time. Okay, now I want you to remember these words: cat, cab, cad, cap, mad, max, mat, man, map. Write down as many as you can remember. And now remember these words: great, large, big, huge, broad, long, tall, fat, wide, high. Write down as many as you can remember of those. Which brings us on to our last difference between short-term and long-term memory, which is coding. So we've looked at capacity, duration, and the last one is coding. Sometimes it's referred to as encoding as well. So information that we store has to be written in our memory in some form, and that's how you can look at coding. It's the way that it's stored or written into our brains. And it's usually in sounds, so remember things acoustically, images visually, or meaning semantically. So the word list that I gave you to remember, these cat, cab, cad, cap, mad, etc., those are acoustically similar because they sound similar, but they're semantically different because they mean different things. Whereas great, large, big, huge, broad, tall are semantically similar because they're synonymous, but acoustically different. They don't sound the same. So how is short-term and long-term memory encoded? Badley, who I will constantly remind you, my year 13s get sick of me talking about Badley, but he was my university lecturer, so I feel like he's my mate. Basically what he did, he used word lists like these that I've just shown you to test the effects of acoustic and semantic similarity on short-term and long-term memory. What he found is that participants had difficulty remembering acoustically similar words in short-term memory, but not in long-term memory, whereas semantically similar words posed little problem for short-term memory, but they got muddled in long-term memory. And what he concluded from this is that short-term memory is largely encoded acoustically, and long-term memory is encoded semantically. Now, there's lots of students who get muddled up here, because they read the second point and they say, wait, so they had difficulty remembering acoustically similar words in short-term memory, but that doesn't make sense because short-term memory is encoded acoustically. Long-term memory is encoded semantically, so why did they get muddled? Why did semantically similar words get muddled in long-term memory if that's how it's encoded? And how I ask people to think about it is think of it like boxes. So in short-term memory, it throws all the acoustically similar words into the same box because short-term memory is encoded acoustically. So it hears a sound, and it hears a word that has similar sounds to it, and it throws them all into the same box. So they get muddled. So then when we're asked to recall those words, it's harder to recall them. Semantically similar words in short-term memory have individual boxes because short-term memory isn't encoded semantically. So then if we're asked to recall them in short-term memory, it's a lot easier for semantically similar words. There are some problems with the research into coding. So the first one is that Badley may not have tested long-term memory after all. This is because with short-term memory, the participants were asked to recall the word lists immediately after hearing it. With long-term memory, their definition of long-term memory was 20 minutes, which is quite a questionable amount to whether that is really testing long-term memory. So therefore you could say that that lowers the validity because it's not actually measuring what it intended to measure, which is long-term memory. Another problem is that other researchers found that short-term memory may not be exclusively acoustic. So we don't necessarily encode things acoustically into our short-term memory. Brandy Note found that participants used visual coding in short-term memory if they were given a visual task, so pictures, and prevented from doing any verbal rehearsal, if they had to say la la la, before performing a visual recall task. So imagine she was testing acoustically similar words. So she showed the participants pictures of man, a can, a cat. Because the participants couldn't say in their head cat, man, can, that prevented the verbal rehearsal. So all they could do was to remember the pictures. Usually what we do is we translate visual pictures into verbal codes in our short-term memory. But in this study by Brandy Note, because the verbal rehearsal was prevented, participants just used the visual codes. So when recalling back the information, they didn't remember the acoustics of the words, the sounds of the word. What they remember was the visual, which shows that short-term memory may be actually encoded partially visually. And the last evaluation issue is that long-term memory may not be exclusively semantic. So short-term memory might not be exclusively acoustic, long-term memory may not be exclusively semantic. This was found by Frost, who showed that long-term recall was related to visual as well as semantic categories. So again, found that our long-term memory may be encoded partially visually as well. And Rothbart found evidence of acoustic coding in long-term memory. So encoding in long-term memory is not simply acoustic or semantic, but can vary according to circumstances. Your last task for this lesson is I've given you 7 answers, and what I want you to do is just write down the questions to these answers. So pause me now and have a go at that. So number 1, the capacity has been found to be 7 plus or minus 2. What is that? It is, what is the capacity of short-term memory? And that was found by Miller. That is Miller's magic number. Number 2, coding is mainly semantic. What is the question? How is material in long-term memory mainly encoded? So in long-term memory, it's encoded semantically. Digit span, what technique can be used to measure capacity of short-term memory? And the digit span was done by Jacobs. Consonant syllable, who did that study? What do we call the group of letters used by Peterson and Peterson to test duration of short-term memory? Duration of long-term memory, what did Barrick and his colleagues study through yearbook recall? The permanent memory store, what is long-term memory? And number 7, coding. What do we call the process by which information is converted into a suitable format for storage? So there you go. You have learnt a lot this lesson. Well done. Please submit your notes onto Teams. Any questions, let me know.